Switchport-Port-security. So when you need to limit the voices that can talk to a switch port, to an interface on a switch, for security or performance reasons, we apply the switchport-port-security suite of commands. The switchport-port-security is implemented with variations of a group of about 11 commands. From the enable mode, go to the interface you want to configure. In this case, we're going out to port 48 of our switch. And then we want to set the switch mode. So these are 3 standard properties that we're going to set for just about every, or 4 sets of commands we're going to use on just about every interface. The first one that we've hit here that has got a couple options for us though is the switch port mode access command. We can have the switch port mode set in access or in trunk, but not in dynamic to configure switchport-port-security. Finally, the switchport-port-security has to be enabled. And that's done so with a switchport-port-security. Switchport-port-security. I always forgot that dash for a while. So switchport, all one word, port-security. And by default, the port security is set up and it is in dynamic mode, which means that it will learn from the source MAC address of any incoming packet an address that's going to associate now with this port. And by default, we can see that information with a couple of show commands. So we can look at the port security command. So that's the show port security interface fast Ethernet 1/0/48, and we can see here that it's enabled, that the port status is actually down right now because there's nothing plugged into it. We'll learn here more about the violation mode, but it starts off as default at shutdown. We haven't set anything up for aging yet, and it's currently set by default with a maximum of 1 MAC address that it will hold at a time. Now this value, this last value, that stays there until you do a reload. We know there's nothing happening right now, so it's kind of a meaningless thing, but it does try and talk about the last address. But if we want to see what addresses are associated with the interface, we're going to use a different show command, a do. Well, since we're in the configuration mode, we'll use the do form of the show port-security address. And that will tell us any or all of the addresses that are associated with the interface, what VLAN they're on, and it also gives us an indication here of the minimum and maximum that can be used. So if 1 is the default number, MAC addresses there wouldn't be any MAC addresses that are allowed. And on this hardware, we have a table, 6,144 MAC addresses that are in this port security table. So that whole 61,044 is split up amongst all the 48 interfaces that are on this table. So you can set them up any way that you want, but that's the maximum size, that's the maximum number of entries we're going to be able to work with. So the next topic that we want to cover is the different ways that addresses can be collected. We've already talked about dynamic addresses. So we can see that once port security is enabled and we've connected a valid Ethernet connection to the port, and the port is enabled, so it's not shut down, we get a notification that tells us that the state has changed, and when we issue the do show run interface, we get information about what's going on the interface, and then when we do a do show port security on the interface, we see that it's enabled, it's up, and we have one MAC address that's been assigned. We also have one MAC address showing here in the last source MAC address VLAN, the 00F.B0FF.AC3D:1, and we're hoping to see that same address when we go look at the do show port security address. So here we go. We do see our address. It's the only one that's there. It's secure. It tells you the type of address it is here. It's a dynamic. We learned it from the cable that's plugged into port 48. And we're going to leave this port in dynamic mode. We're going to just take the single computer Ethernet cable. We're going to plug a cable from another switch into this port. And so we unplugged the cable, so we saw it go down. We plugged in the new cable. We saw it can't come up. And we saw the state change to up and the line protocol, and the state changed to up. And now we're going to go take a look and see if we're collecting some more addresses. It doesn't say we've got anything yet. Take a look at the interface on the port. So the issue here is that we had a maximum of 1. So because we have a maximum of 1, and we tried to, you notice that this address here is different than the one we had up here. So we had a maximum of 1, we got a different one that came in, and we got a security violation. Okay, so we're going to try and do a couple things to make that work for us. First, we're going to go to the interface, and we're going to change the maximum from 1 to 10. Well, we'll change it from 1 to 100. Let's see if we can just collect. Let's just see what it looks like running, and then we can violate it again by going over the max. So we're going to go to our fast. You're going to go to the interface on fast Ethernet port 1/0/48, and we're going to run a maximum of command. I think we won't have more than 100 addresses coming off of that port, so we'll set it like that. And we'll check the configuration out for the whole interface here. So that's what we want it to look like. We know that we're in an error state, so we'll go ahead and take a look at our interface status and see what that interface. We know that because we've got the security violation information here. So we'll take a look here, and this is what we'll see. This is our telltale sign, error disabled, when we have a security violation. So to get out of this, we're still in the right interface. So we're going to do a shut, and then we'll do a no shut. Okay, so it changed administratively down. Good. We'll do a no shut. Okay, came to up. The same cable has remained in the port, so let's go see if we're collecting MAC addresses now that are allowed on this port. We're still in dynamic mode. We set a maximum of 100, and now it's got the first one still. And still working on the first one. We've got a whole crew of them now. Notice we're in dynamic mode here, and we're collecting them. You can see that all of these addresses were learned dynamically. And we'll run them a little bit more. So we have a total of 8 that we've learned dynamically now. So that switch isn't hooked up to a lot of devices, but we've got 8. And we learned them all dynamically. So we don't have to just learn these dynamically. There are other ways to learn addresses. We can assign an address. There's a couple things that I want to point out before we switch over to statically configured MAC addresses for port security. And that is that when we look at the configuration on the interface itself, there's no configuration for any of these MAC addresses. So they're kept in NVRAM, but they're not configured into the running config. They can't be saved to the you can't save the running config to flash. These addresses are transient based on the next reload, or the next shutdown of the interface. So and when the interface comes back up, we're going to learn a whole new set of things. So we want to try this a little differently. We're going to add a manual address by using just a different port, a different form of the switchportPort-security command. So we're still on that interface. And if we use this switchportPort-security MAC address, then give it a valid MAC address, now we've just added another address to our port security. So now instead of 8, we're up to 12, and look, this one says it was configured. Okay, good. And not only is it configured, but if we look at the configuration of the port, we can see that now lives in the running config file. It can be saved to NVRAM and make it static over shutting down and recycling the port with a shut no shut, or even through reloads. We will get this configuration will stay. So we've got another option that we can do. We can combine both dynamic and this ability to have the MAC addresses survive through the reloads and interface shutdown, shut no shut cycles by using an option called sticky. So by using the switchport sticky command, any addresses that are learned from here going forward well, actually, you notice these changed from dynamic to sticky. So when we go and check the configuration of the port itself now, all of those dynamic addresses were turned into sticky addresses, which means we learned them dynamically, but we configured them. Now we've configured them so they're both in NVRAM and they're in the running configuration file and can be saved. And this that exact configuration can be allowed between between interface shutdowns and startups, shut no shut cycles, and reloads of the switch. So we've talked about our 3 types. Dynamic, which doesn't show up here anymore, but we can see these were all dynamic before they before they were sticky, because we learned them. Once we learned them dynamically, and we had a total of 12 here. Once we learned them dynamically, and we configured the sticky option, they turned into sticky objects, which means that they are both in NVRAM and they are configured in the running config, and we can save them and they can survive through no shuts on the interface and reloads of the switch itself. So there are multiple ways we can clear the ports, the MAC addresses from the ports that we've already learned. Let's start off by taking a look and see what we've learned, or what we have stored in the interface itself. So we'll take a look at the configuration of the interface. Show run interface, fast Ethernet 1/48. Okay, we can if we remove the sticky command, so if we use the no form of the sticky command, then we get rid of all of the interfaces that were configured with sticky. So they're all gone now. The only one that's left is the MAC address that we've learned, that we've specifically put in, and that can be removed from the configuration with the no form of that command. And now this interface is back to running in dynamic mode with a maximum of 10 addresses that it can learn, or a maximum of 100 addresses that it can learn. So we take a look at the port security status of the port. Just because we lost the configuration of them, we're still running. We still have 100. We've learned 20 MAC addresses, and we're still within the realm. However, if we what happens if we go over the limit? So we're going to change our limit down to 10. That's going to put us into an error state, and we're going to have to, and the interface will completely shut down. It won't allow any more traffic in or out of that interface, and it'll be shut down until we clear it up, and we'll do that with a shut no shut capability. So because we are here in shutdown mode, if we incur a violation, so that violation is going to happen because we're going to change our maximum from 100, we're going to change it back to 10. And we'll do that with the switchportPort-security maximum 10 command. Okay, so we can't do it directly. We're going to have to shut the port down, and then we can make the change in the maximum. So we'll do a shut. Now once you've shut the port down, all those ports that we had learned in dynamic mode. So the port security status currently of our port is that there's no MAC addresses. Once we've shut it down, they were all dynamically learned, and now we haven't learned any of them. When we go look at when we show the port security address list, You see that we don't have any that we learned here. We're going to set our maximum now back to 10. And we're going to do we're also going to change something. We've already seen what happens when we have a violation and we're in shutdown violation mode. The port completely stops. But what if we're in restrict mode? Restrict mode is a little more forgiving. It drops packets. But in restrict mode, and we get a violation, then we're definitely going to drop the packets. We're going to send notification. In our case, it's going to come to the console. The gateway is going to generate a syslog entry, and it's going to generate an SNMP trap that can be sent and notify people that there is a port going on. But the port will not be shut down. So let's make that change. We'll switch from violation to restricted mode, which is our medium tough. We still throw the packets away, but we don't shut the port down. So let's go ahead. We've still got our switch port. We know that we had 19 or 20 addresses that came from there. That's more than our 10. We're starting off without any, so we're going to do a no shut, and we'll watch our addresses as they come up. So our interface is coming up. And we'll take a look at our okay, should be getting something soon here. Okay, there we go. We're up to 6. You got 7. We're up to 8. Okay. 2 more. We ought to be hitting our violation. There we go. Boom. So we're in restrict mode. So we got a security violation. It was caused because this MAC address on this port. And if we look over here, we are already set up for so when it hit that 10th one, we got a security violation. So but if we look at the interface status, it's not completely shut down. Right, so it's not sending no shut in the configuration, the status of the interface. So we got a syslog, we got a notification, and we got an SNMP trap that could have sent off an alert, but we didn't shut the port down. Now here we're getting another MAC address, and here's our second violation. And we look in our interface, if we look at the port security status for our interface now, we can see that there have been 8 violations that have occurred. We said we wanted 10. We have 10. Now there is here we've got another violation, so we should probably see our count go up. Yep. So our violations now are up to 10. Okay. So all kinds of different things are happening that we can see. We got a counter that's going up, we got notification. In the background we have syslog entries, and we have SNMP trap messages that are being sent out. with this information as to what MAC addresses are having the problem. Okay, so we're going to change one more thing on our interface. We're going to switch from violation restrict policy to a protect policy. The protect policy is a little easier on everybody. It doesn't send out any notifications, syslog messages, SNMP traps, but it does continue to up the counter. So as we watch our port security, you can see now it's up to 12. Should watch it here, we will have more. But we won't see any notifications. We'll give it a second here. In this portion of the video, we're going to talk about the aging option. There's several aging parameters that we're going to be using. They all start with switchportPort-security, aging, stat, and then aging, and then something that's after that. So we enable switchportPort-security aging static, which we have configured here, which means we are going to age the statically configured addresses that we've associated with the interface. So to start our view here, we can see that we don't have any addresses statically configured to the interface at this point. So we'll go ahead and create one. So the port is in shutdown mode, so we're just kind of setting up to see what happens. Okay, so now we do have aging set up. We have aging static, which means it's enabled even for this static member. It's going to set a timer of 2 minutes, and its configuration by default is absolute, which means we should be able to see this address in our list of addresses, MAC addresses, in the per port MAC address table, and we should actually see it time out. So we'll start off with an initial view here. We'll look at the port security status of the interface. So stuff's enabled. It looks like it's going to be down. We're in protect mode. We're running aging as absolute mode, and our aging timer is 2 minutes. And for addresses, the only thing that we have configured, the only thing we have for this address is the one that we just configured, and it says we have aging and we've got 2 minutes to go. So when we do a no-shut on this interface and watch these things happen, this is, so we went from 2 minutes. It says it's in the it's got at least 1 minute to go. So it's 1 minute and some number of seconds. We're starting to get some dynamic addresses, and notice that they are also showing up initially with the 2 minute absolute limit. So we've got a bunch more addresses coming in now, but let's keep our eye on that secure configured. Kind of start a watch here and keep abreast of the time, because we should have to see that once it gets down below a minute, we'll see an indicator saying that it's less than a minute. In the meantime, we can kind of keep watching here. And now that configured address is less than a minute. So we're still able to, the static parameters got, you know, the configuration in the running config file as well. So let's see when it times out if that goes away, which we expect that it should. Alright, so there's our config. It's configured statically. Keep an eye on our addresses. Now I've got a bunch of these addresses that are going to be going away, aging out. But the one that we're mostly looking at in this demo is our secured address. They're all secure. It's our statically configured address. And it's gone from the address list, and it's gone from the running config. Now we're going to expect that some of these addresses that go away, we'll keep an eye on this top one here, starts with 005. It's going to age out as well, but we expect it to come back in because that it was learned dynamically once, it'll be learned dynamically again. So we'll just keep an eye out here, and look, it actually, we know that it went away and already came back because it's showing 1 here, and it wasn't less than 1. Now it shows it 1 for the time between 1 minute and 2 minutes. In a few minutes it will. So when we use the point here is this: when we use the switchportPort-security aging static, we enable aging of the manually configured MAC addresses. So we're going to change that up a little bit. We're going to get rid of that, because if we manually configure them, we don't want to just throw them away, at least not usually. So we're going to change the configuration now, and we still have aging enabled, and we set our timer for 2 minutes, but we're going to stop aging out the manually configured MAC addresses. So to do that, to show that, we'll put our manually configured MAC address back in. We'll just double check our configuration. Looks good. We're going to watch the status of our port security addresses for this interface. And now we have our configured address back in there. Notice it has a dash, and this dash is going to keep this address from the aging pool. So the age of 2 minutes was just selected to demonstrate addresses coming in and out of the address pool per port security address MAC address pool. I wish this had a name. I'd like to call it the per port MAC address table. and I think I will in future. Alright, so we've seen the switch port aging static, which allows the timeout of MAC addresses from that are manually configured. We've seen the effect of the switchport-port-security aging time, and the time set to 2 minutes, which sets the limit of time, and by default it affects all of the dynamically learned addresses. The time limit is, well, the time unit is minutes, and the limit is 0 to 1444 seconds. Now, I was wanting to check, and we've currently got it set to absolute. I want to do 2 more tests here. I'm going to set the time to 0, and I think effectively that stops any MAC addresses from being learned. So if we set the age time in this interface to 0, oh, got some bad doobie there. It's not valid. Okay, just a documentation error somewhere. So 1 and 2 is the only options we have. So that takes care of that question. And finally, let's change from absolute aging to inactive aging. So if we just set the switch port security aging type to inactive, inactivity, and now we watch the status of our per port MAC address table by using the do show port security address. Then we're keeping an inactive timer that shows how long the address has been inactive. Our statically configured device doesn't change, it's not participating in the aging. And I'm trying to look for some differences between the two. So there's one difference here. So what we saw here is that this had gone less than 2 minutes and was inactive, inactivity, so it was counting down somewhere between 2 minutes and 1 minute. And then it came in again and had some activity, and it reset its counter back to 2 minutes. Okay. So the last thing that we're going to work on is we're going to change these addresses. We'll take a look at the configuration once more. And we are going to add the sticky port security command. So that's going to be switchport-port-security MAC address sticky, and we'll leave everything else as is. And we'll see how that affects us. If at all. Okay. We'll check the status, the port security status of our interface. Everything still looks normal there. We'll check our port security addresses. We can see that they've all switched to sticky, and now none of them are being affected by anything to do with aging, because effectively we've turned our dynamic addresses into statically configured addresses, and so the aging is not doesn't affect those addresses anymore. And that's the end. Thank you. I've learned a ton by trying to do this. One is how boring it is to listen to me.